All right, recording is on. This is the Kubernetes Network Working Group or Network Plumbing Working Group meeting for March 1st, 2018. And first on the agenda were spec updates. I went back through last week's meeting and updated the spec proposal for stuff we talked about, and there were only a couple of those updates. The first one was loosening the requirement for the kube network object name to match the CNI JSON config name. So I updated that language, and the only question I had was that the CNI plugins currently get the CNI JSON network name, at least, sorry, in the spec. The plugins would have gotten their network name from the CNI config JSON, and now if that name no longer matches the kube network object name, they won't be able to get the kube network object name. If that is a problem, then we should figure out how to address that. Maybe that's not a problem at all. Does that problem make sense, Mike, since I think you were the person who proposed detaching those originally?
So what did you say is the resolution?
Well, there is no resolution at the moment. It was just a question of if the kube object network name is not the same as the CNI config JSON name that gets passed to the plugin, plugins only get the CNI config JSON name because, you know, I mean, they get CNI config JSON when it gets sent to the plugin on standard in. So if they no longer get the kube network object name because those are different, does that matter from a plugin's point of view? Do we care?
Yeah, I don't see why the plugin would care.
Okay, well, I mean, it would just mean that the Kubernetes network object name is different, obviously, from the CNI name. And so, okay, if you don't think it's a problem, then that's fine. We can just punt on that to see if it comes up in implementation.
My whole concern was in usage.
Yep.
I think in implementation that should be a non-issue. I mean, it'd be easy to implement either way. The issue, all along, I thought the issue was usage. A, we would like to prevent people from making mistakes, and B, we don't want to necessarily tie external network names to the Kubernetes restrictions on object names. Plus, of course, these are not naming networks. These are naming ways of making network attachments.
Fair enough. All right, well, we'll just leave that as is, and if that ever comes up, we'll revisit it later. Again, I don't think it's a huge deal. It's just something I was thinking of when I reworded that language. The next item for the spec updates was I added some notes on versioning. We talked for 5-10 minutes last time on CNI versions, so I tried to add some notes about that. It turns out that I don't think we care that much right now. The only time that a meta plugin would need to care is if it is constructing the minimal CNI config JSON when the network spec.plugin field is used. And that would be for kind of like the thick plugins that we have been talking about in the past. And there, you probably want to use like CNI version 0.30. Because that enables you to get back the list of interfaces and things like that that could then potentially be put into the status. If you don't
0.30
specify,
has a bug. Have we wanted to go to 0.31 at least?
okay. Well, oh yeah, is that the int thing?
That was the name of the plurality in the name of addresses or something.
Got it. All right.
There was some tiny thing, but it should 3.1.
Fair enough. It is updated now to 3.1. In all 4 of the places that I think I had changed it. Okay, so good, that's done. Yeah, and so that's the only time that I think the meta plugin would actually need to specify the CNI version. Everything else with versioning, I think, works more or less as it does now. And if the plugins conform to the CNI spec when the meta plugin calls each of them, they should do the right thing, which would be if they don't support that version, they error and then the whole call fails, just like it currently would.
I can hear somebody typing.
So that was it. Sorry, go ahead. All right, that was it for spec changes that came out of last week's meeting or last time's meeting. Were there any other thoughts, comments on the spec? It seems like we are kind of running out of additions and major changes to the spec. So if nobody has any other large comments, there was also the open question of the alternate network selection annotation proposal. Maybe we should find some closure on that. And I think there was two options on that. The first one was we either go with that alternate proposal, or I think Mike suggested in the last meeting that it would be simple enough for plugins to figure out, to like auto detect whether they were using the extended version in the alternate network selection annotation proposal or whether it was using the simple comma separated list.
I like the idea. This is Doug. I like the idea of having both of them. I mean, I lean sort of towards the JSON one, but yeah, supporting both. I feel like it's not a big deal to detect between comma separated or the JSON.
Okay. And since you're working on implementing some of this, Doug, that is great feedback. Let's see here. I'm just going to take a few notes here really quick so that I know what to do next time.
Do we really ever want comma separated instead of a list?
It's easier to do in JSON, I guess, and it kind of follows some of the other models that a lot of annotations have used. Or sorry, not easier to do in JSON. It's easier to parse than you can do a string.split instead of having to.
Yeah, I guess the one thing I would say about the comma separated one is that it may be easy for a user to type in if they're just trying to say, I'm whipping up this quick and I just want to say this comma that comma the other thing, rather than being like, oh, let me type in all of this and then lint it or whatever. So there's something to be said for that. But I mean, I like reading the JSON. I don't mind typing it. But anyways, thinking about whoever might be just whipping up a pod spec quick or a resource definition to be more technical.
And I think that does have value. If we want people to be able to do this quickly and just kind of fire off and test even, I think we want to try to make it as user-friendly as possible. We want to be able to allow the flexibility for other stuff, but I do think it has value to kind of keep the non-JSON-y comma-separated list.
Totally, because probably the primary use case is to say, I want this network, comma, that network, comma, the other one. And then sometimes you might be like, oh, in this particular case, I actually have to specify more than what I need, and it's worth the time to input all the JSON.
Does that make
So
sense,
Mike? Yeah, I kind of understand it. I mean, there's, a countervailing thought that if this really is a list structure, let's just go ahead and say that. Putting other syntax into strings when we already have JSON syntax at our service seems, it kind of offends my sensibilities. But I understand that, quoting JSON in YAML is a little bit painful. But, I mean, there's an easy way to do that. It's not a big deal to me. So I'm not going to make a big deal of it.
Okay. I think it was actually you who suggested that it was easy enough to figure out which one was which.
Sure. But I'm saying, no, but my point is, we're talking about,
right.
If we're going to offer two choices, I'm saying the simpler choice, if it logically, semantically has a list structure, to my taste, I would use JSON structure to express the list. That's all I was saying. But, if you guys want to go with a commas string with commas, it's not a huge deal.
Okay. So the decision there then would be that we will go with both. I will try to formalize that alternate proposal there and make that language a little bit clearer.
Awesome. Thank you.
Yep. Okay. I think that was it. Next steps for this proposal. Obviously feedback on the language. We should probably get some people dedicated to just reading over it and making comments where the language isn't clear, where the language is ambiguous, and just try to tighten it up a little bit. Most of it is just me typing stuff, and I'm sure I've made some mistakes. So at the very least, can I delegate Mike and Doug to take a look at this over the next 2 weeks and just kind of go through it? And
yeah, I have to apologize for not paying more attention lately. I've been really focused on something else, but I'll put time on.
I have to say the same thing too. So if you just make sure that there is a link I can follow, I will put some energy into it. I had my mother being really ill, that's why I've been off the last month.
Okay, no problem. So what I will do then is I will send out a mail to the sig-network list with the link and the request for that.
Sounds good.
Very good. Thank you.
Sure. All right. So the next thing I had on the agenda was kind of like some decision on the network as resources proposal that I think, was it Yaniv or Dan Koenigsberg had kind of posted in the doc maybe a month ago. It sort of keeps coming up, and the reason why I brought it back into this document was that the resource management working group, and Jeremy is sort of representing that group here, and he's on the call, and also he did a short presentation on some of that stuff last time. They're continuing to go ahead with a number of different proposals, and also I think Fabian Deutsch is on the call as well, and he'll be talking a little bit later. So anyway, the resource management working group is going ahead with a number of proposals that are sort of exploring this direction. And I think in the future, it will be somewhat important to try to figure out how we do management of limited resources on the nodes. And obviously that doesn't really make a difference for SDN type networks, but if you're a non-SDN type network, or if you want to try to bring in some kind of hardware resource on the node for your networking, we're going to need to think about scheduling and resource management. And so anyway, I brought that back because it seems like something we probably want to think about for the future. But my suggestion, and I'm totally open to what anybody else thinks. My suggestion would be that we add it to the previously discussed topics section at the bottom and decide to investigate it further in conjunction with the resource management working group as kind of like an enhancement to this initial spec. What I would like to do is try to keep this one simple for now, just get to kind of like a V1 of the specification that people can actually start implementing and start poking holes in from an implementation perspective. And then we can circle back around and update that with some of the other ideas. I don't want to necessarily lose this idea, which is why I like to add it to the bottom, obviously. But keep it around, but I don't think that we should add it to the specification for V1. Does that make sense to everybody? Are there any alternate opinions?
It's okay with me as a road mapping idea. I completely agree this is an issue that has to be addressed.
Hey, I'm Fabian Deutsch, and I'm actually also a fan of that approach, but I think it absolutely makes sense to consider that for a later point in time and not diverge the current discussion.
Yep.
That idea.
Yeah, I mean, further point on that, having been on some of the calls with the resource management working group and seen some of those proposals, it still seems like it's under active research and active development and investigation. So I'd like to see what comes out of that and kind of iterate on that.
Yeah, that makes sense. And I think, but why we bring it up so early is because there's some cooperation needed between the two working groups in order to get the device plugins into shape if we want to follow that road. And that's why I think it makes sense to start looking at that, even if it's not in scope right now.
Okay, fair enough. All right, it sounds like there's consensus around that suggestion. So I will make that change as well. Before we give the floor over to Fabian to do a demo of their POC on some of those topics, are there any other things to talk about with the specification or other general business?
sorry, is there going to be more discussion of the device plugin, network plugin alignment, or do we have?
Kind of punting that until maybe after Fabian's demo.
I'm fine with that. I just want to make sure that I didn't blink and miss it.
Yep. You did not. All right. With that, over to you, Fabian. Go ahead.
Yeah, thank you. I just need to get back to, oh, there it is. I just need to get back to my Zoom window. All right, let me try to share my slide deck. I prepared a few slides, like five in total, just to give you a quick intro to what we've been doing. I think that's it. Can you see my slides? Should be a small window.
I can.
Yeah, okay. We need to live with that for now. Let me see. Can I, no, collapse it? No, it doesn't. Okay, so I'm Fabian and Peter, who will be doing the demo. We're from the Kubert project, which is about running VMs on Kubernetes and OpenShift, actually. And we're bringing with us a few requirements on networking, which are also being discussed in this group. They're in this group, I mean, sig-network, they've been addressed in the past year in many discussions, you know, multiple IPs, multiple networks, how can they be presented in pods? And we have the same problem with VMs. We want to provide layer 2 networking to VMs, and we want to provide IPv6 capabilities to VMs, and we want to find a solution. And we've been thinking about that and also following the work here. So what's the state today? The state today is that if you launch a VM with Kubert, by default, it will tie into the Kubernetes networking as best as possible in order to provide maximum compatibility. But we need to provide more to our users because we expect to provide them a solution to migrate their existing workloads over to Kubernetes using Kubert. And because of that, we need to provide them with a solution, for example, to, I don't know, do virtual functions in that VM, which require layer 2 connectivity. So there are quite a few reasons for that. And what we also want to do, I mean, Kubert itself is an add-on to Kubernetes, so we are implementing an operator pattern, and we want to do the same thing for networking. So we want to see that we can add our networking to the Kubernetes cluster without harming any core parts or requiring changes on the node. So that was driving our thoughts. Right, so when it came to networking, I said we followed the sig-network discussions, but at some point, like at the end of last year, at last KubeCon actually, KubeCon North America, the idea emerged, speaking to Yaniv, who presented it earlier, and then later sharing it with Dan, who also presented it here, to consider, actually because of the work which was done in the resource management group, to consider networking host resource. Because the device plugin is, if we look besides the actual API, it's a concept to bring host resources into a pod or actually into a container today. And networks can just be considered to be one of these resources. Today, it's mainly about GPUs, but networking like physical networks, so InfiniBand devices or virtual function devices, overlay networks, layer 3, layer 2 networks, all of these can be considered to be resources, or at least, excuse me, or at least we think they can be addressed just like other resources on the host and be brought into the pod in order to be consumed by the workload. Actually, we also think that SIG or managed networking, you know, like what is happening with Courier or with other backed plugins could also be solved in this approach. So what did yeah, okay, and now a small exchange to device plugins. I'm not sure how familiar everybody is with device plugins. I'm not sure how much Dan and Yaniv said about that in the past. So
can I ask a question? Before you go on to device plugins, I want to ask, what's a resource?
Oh, resource. Yeah, that's, you know, they use the term resource, and Jeremy, please correct me if I'm wrong, but currently the term resource is used. But the proposal came from the GPU direction to make virtual or GPUs usable in pods for computing reasons. So today it's pretty much tied to GPUs and some, I would say primarily to GPUs, but they use the term resource. And to me, and that's why I was following this approach, is that the pattern they take, they expose a quantity of a specific resource for a node. That is what device plugins do. You start a device plugin. That device plugin is looking on your node. Is that resource which I was developed for, is that present on the node? If it is, then it is exposing the quantity, the capability on the node API to the cluster level. And
so a resource is fundamentally a quantified thing.
Today, resources are quantified thing, yes.
Mike, the word resource comes from the block in the API called resources, which today only holds CPU and memory.
Oh, right.
Okay. Right. I'm thinking about just the semantic basis here, right? So if we're talking about virtual networks, for example, there is no host resource being consumed when I make a connection to a virtual network. If it's like something like with VXLAN, for example.
Yeah.
And I understand if we're talking about, PCIe virtual functions, there's a host resource, but a network connection is not itself necessarily a host resource.
I mean, it depends on the interpretation. For overlay networks, we could say it's a host-provided resource. So you need some kind of host setup in order to provide it to whoever is consuming it. So Kubernetes in that example, or CNI, whoever. So it's a resource provided by the host to be consumed. And also, that overlay network will also go over a physical device out of the host. So there is room for interpretation, I agree. But on the other hand, it is a resource which the host is providing, which you can consume with a pod.
So can I ask a question, since Mike, you just touched on basically the first note that I wrote for myself. The description of networking as a device or as a resource is a little bit vague, because by my count, I can count at least 6 different modes of accessing virtual networks. I could be requesting a specific NIC. I could be requesting access to a specific network that's connected to a fixed set of NICs. I could be accessing a specific network connected to a fungible set of NICs. I could just be getting access to a network, but not necessarily sole access, like not a dedicated device, to a fixed or fungible network. Or I could be asking for essentially an unbounded thing, like the VXLAN case. And whatever model we pursue here sort of has to comprehend that and address it.
Yeah. So,
right. I would say also a little bit more fundamentally, even, right? In some sense, in plain English, everything's a resource. But when you make an API, you have to have some semantics, right? I mean, objects are a resource. The ability to create objects is a resource. Electricity is a resource. Clean air is a resource. I mean, just because in plain English you can call something a resource doesn't mean we should shoehorn it into the Kubernetes resource API.
Right. So on the other end, I wonder what makes networking so specific. So first, I agree. There are different ways how you can consume networks and how you can actually attach them. I mean, the best obvious example is, for example, for VMs, PCI pass-through in order to directly attach a NIC into a VM using the PCI pass-through mechanism, or bridge it onto that device. So there are different ways how we can consume networks. I don't disagree with that. But that is different ways of consuming the resource, and you could expose them in different ways how the resource, you can express them.
They're different resources.
Yeah, so that is what I wanted to get to. Sorry for not finding the right words right away. But yes, you express them as different resources. That's actually what we'll see in the example later on. That you could express the same physical device, for example. Let's say it's a physical device. You could express it as a layer 2 device if you want to get access to the network interface, but you could express it as a PCI device in case you want to do pass-through. So it's a different resource depending on how you want to consume it. The point, so we can discuss about that, if it's feasible to say networking fits into that class or not. But the reason why we did it is that the device plugins in Kubernetes actually have some things which, and I'm sorry about that, they have some things which make it appealing and which we see is emerging here as well. For example, they already have a way to for deployment and how to speak to the kubelet. They have scheduler awareness, so on the fly they can detect if a resource is present or not. That is really handy for example, managed networks. And they have API integration, and I mean that is what we're currently seeing with the standardization of the CRD, which is not conflicting, by the way, with this proposal here. It's rather a more fine granular addition to it, but it has API integration. So today you can specify in container spec what resource you want to consume. So all of this is there, and it works. And that is why it's so interesting. And I wonder, and that is what is wondering me, if we want to invent something very similar for networks as well, or if we can't find an approach where there's a generic device consumption approach or a resource consumption approach, which then, for example, is using resource classes to specify more device-specific parameters.
Right. I mean, I think I think this is a really great slide. Right. You've got something here that's really important. Two things are really important, and one that's not. And this is really my criticism. Right. So I understand why the fact that you've got something that's going to do your easy deployment and is already integrated in the API. Those are great features. Right. And the scheduler awareness, the fact that this is a quantified thing, that's spurious here because these things are not necessarily quantified. So I think what my take on this so far is you're really recognizing there's a broader class of things than what is currently being addressed as resources, as a technical term. And maybe there ought to be some recognition of this broader class of things. At least that's what I'm getting.
Yeah. By the way, that is sorry for interrupting, but that was exactly, by the way, for the quantification of resources. That's actually also something which is discussed on other ends in that resource management group as well, for other resources other than networking.
So the resources in the device plugin API seems to fit a model where you have discrete things that don't really have relationships to each other, right? If I ask for a GPU, I don't really care which GPU I get because they have no relationship to each other. They're not connected to each other. If I ask for a NIC, that is sort of insufficient because I'm actually asking for a connection into a larger system, right? A NIC on its own isn't useful. And
I think some would argue with you on that specific point, Tim, but your general point definitely.
I mean, what are you going to do with a NIC if you can't specify to which network it connected, right? Either I have literally like hardware NICs where they have wires pre-routed to particular networks, or I have SRIOV NICs, which are going to be hooked up somehow to virtual overlays or virtual channels. Or I have these software-defined things which are connected through software mechanisms in the same way. But in all cases, I need to actually, what I really am concerned with specifying is the network that I want to join, not the NIC that I want to join it.
I completely agree with you. I mean, there is a topology on the outside of the box.
Yeah, that's perfect. I mean, that's absolutely right. That is actually, so maybe the problem here is that the device plugin is really just a mechanism to model all this. And you know, the resource, I should have written down a few examples of how the resources look, because effectively it depends on the plugin itself, how it exposes a resource. So you don't have to expose at all a device itself. For example, for any if we imagine a plugin which is speaking to Neutron, for example, you wouldn't imagine that this plugin is exposing any physical devices. It would rather expose the number of networks known by that Neutron provider. So, and then on the fly, the pod can be connected to those networks. So the plugin is so the plugin is advertising as resources the known networks and not any physical connection. But that's also the charming side of this approach, that you can expose different or networking as different resources. So you can expose them as really logical networks. You can expose them as physical devices. It depends on the use case. For example, if you want to do, I don't know, some peeking into network traffic, then you might want to really, bridge to a specific device or put a specific device into permissionless mode. And that can be modeled as a device plugin. Actually, on a slide later or in the end, we have a specific CNI slide, and we can get to that later on now. But my point is, and I'm not so up to date here, so please excuse me if I'm incorrect. But with the network CRD, we also specify networks we want to get attached to. And all of this can be, and this is a rough guess, we have not done it, we'll be working on that, or we'll take a look at that at least, to use CNI actually to perform this network plumbing work. Because as said, DP is just a way to leverage the API and make the schedule awareness, but use CNI and all the plugins which exist there to do actually the network plumbing. So it's a pretty big hammer which might be used, or yeah, could you put it that way? It's a mechanism. It's not a final solution for everything, but it's a mechanism which I think makes sense to look at in order to seek for some alignment.
So the interesting part here is that there's a non-obvious relationship between the network and the device plugin that isn't portable and that users shouldn't really be exposed to if we can at all avoid it. The user wants to say, connect me to this network. Sometimes that's fine and there's no device implications there. It's just going to be a VXLAN thing. And other times it means allocate me a specific NIC on a specific pool of machines so that I can get access to this physically guarded network. But the user shouldn't be aware of that, right? And so what we end up with is a sort of backside relationship between the user's expression of connect me to this network and some other entity's understanding of, oh, that means you need an SRIOV device, or that means you need to run on machines that are labeled connected to SecureNet, right?
Right. So I don't want to get into that rat hole or let users decide to know about all these details. So this is actually the best example I have in one of the documents to express that. So here, this is how we'd imagine an IPv6 connection to look in a pod definition. So here, the important part is actually down here, and that is encoding how the resource is looking. So you've got your vendor string, which is the first part before the slash, and then the resource to consume. And here is that abstraction which you're looking for. We're effectively saying, I want to consume net A from the given vendor or the given provider. And this provider is encoding that's an IPv6 address which we want to consume in that pod. And you can model many things along that lines. So if we take the example above, here we explicitly provide a vendor or provider string, which the terms it is, to expose a specific physical device to the pod. So it's really up to the plugin how to advertise the resource to the pod or actually to the user and how he can consume it. So
but how does a user specify that without being aware of the hardware topology of the particular network that they're requesting?
I would think that, this probably is intrinsic to a lot of hardware devices, and I feel like a GPU is even a fairly decent example too, and relative to what we're trying to do here. But with a GPU, for example, you might care about what kind of chipset is on that GPU, depending on the type of algorithms you're gonna run on it. To me, that sounds pretty similar to, oh, I need this particular capability out of a NIC.
Yeah.
But there's a difference in that there's really not such a thing that I'm aware of as a software emulated GPU, whereas there is such a thing as a software emulated virtual NIC. And if we expose to an end user, hey, you have to request, even if we go through the, there's a secondary proposal that isn't been covered here. It's called the resource class, which provides something like storage class, which gives you an abstraction in between the actual device and the abstract name that a user uses. But even if you considered that the user says, oh, I need to request a virtual SecureNet NIC, I don't know what that means, but it's a SecureNet NIC. That NIC may be hardware or it may be nothing.
Hmm. Oh, it's up to the device plugin to decide that. I mean, the device plugin is reporting the resource, so all the logic to make that decision is in the plugin, obviously. And that can be hooked up to some management plane behind it.
So let me see if I understand. The idea here is that for each distinct network class, there would be a different limit. So I see on the screen here two network classes. One is phi.network.kubevert.io and the other is 6.network.kubevert.io. Right? So depending on what network class, I use a different key in my limit.
Yes, so that's obviously a gap in the API. So today you need to specify the quantity of resources you want to get. More than one might make sense, but it often doesn't make sense. So here we would probably, here's some work to do with the device plugin, or at least to evaluate, in my opinion.
I think you answered a different question.
Okay.
Which is the one is kind of spurious. Right, I'm not asking, it's not like there's a real, I have either choice. I would always write one.
Although,
Right.
Mike, if you write two here, do you get multiple attachments to the same network?
Yes. For example, in the SIG case, I mean, the semantics are up to the plugin, but for it at least makes more sense for the IPv6 example. If you put a 2 here, you would get 2 attachments to the network A.
Would it, sorry, go ahead, Mike.
Sorry.
So I was just going to complete, I think Fabian's answer to Tim's question is that the abstraction is here because all the user has to know is what key to write in the limits. And the mapping to whatever kind of physical resources is behind that is abstracted away.
Or, I mean, it could also be logical networks as well.
Yeah, that's what I was about to add.
Right. The point is that the key in the limits struct here, right, what we see here is this key, this name, right? Limit is a bunch of name value pairs. The names are what the users know, and they're not concrete in the sense of they're not tied to one kind of resource or another physically.
But actually, here's actually where I see the connection to the network CRD which is taking place currently. I mean, this can be a reference to those CRDs. I mean, the red or blue, which are now added, could be really. I mean, there would be. It's a far fetch. That is why I basically agreed with Dan that it's something for V2. But to me, it's still charming, and the detail. It needs to have a close look and actually think a good discussion about the ends of it to understand if it makes sense or it doesn't make sense.
So if I'm a user, how would I specify what the blue network is?
Oh, that's up to the device plugin. So for example, if we say the blue, we imagine it's a scene. So first, the resources which are provided here, they are provided by independent plugins.
I lost connectivity.
So,
and just to be clear on that, the resource that you're talking about is networks.kas.io/red, right?
Exactly.
That's the name of the resource.
Sorry, what was
That's the name of the resource. That full thing. It's just namespace this way because of convention, right?
Yeah, that's the vendor of the plugin. That's
right.
The vendor. The resource is actually red. So if we imagine that networks.ks.io is the reference CNI plugin from Kubernetes blessed by you, for example, and that is watching for all network definitions on the cluster. So looking for network CRDs, and whenever such a network is defined, then that pod can be connected. Then this red network resource is available on the host or on any host where, I don't know, if the CRD will have node selectors or something like that. Then a user can decide to consume that resource with that pod. The scheduler will actually make sure to schedule that pod on a host where that resource is available. So it's up to
yeah, this is strange, right? So if I write a CRD defining a red method of making an attachment to a network, then before anything can use it, somebody has to update every node. It's a virtual network that's everywhere.
So we have these daemon. I mean, at least in the NVIDIA case, we have these daemon sets, that run these device plugins, and hardware and write everything out to update the node spec capacity and whatnot as the allocate and deallocate calls occur to the device plugin. So we're putting a lot of the magic, and this is where the vendors do their value add to the extension point. We've added the device plugin extension point.
Yeah, and actually we'll see it. I mean, Peter will show it in a minute, how available resources will pop up on the fly. So your device plugin is watching the cluster, and it will watch for newly defined networks. And as it sees them, it can do any setup locally on the node once it discovers these newly defined networks. Whatever that backend then is, it depends on the vendor. You might want to do everything with VXLAN, you want to do it with Flannel, whatever, or Weave. It doesn't matter. It depends on the vendor.
So, for example, if I've defined 1,000 virtual networks using VXLAN, then something has updated every node to have 1,000 resources.
We sort of already done that at Kaloom. We call it the what do you call it? Pod manager. It's sort of a pod manager that for each pod basically looked at all the services. And when you added a network to it, we pull that network up from through the CNI and attach it. And it's similar. You need to look at the specs and see when our network's defined and then pull them out.
So there's a problem here. So I think I'm starting to understand. I think that the change of the example to red and blue actually illustrates a lot better than the previous.
Yeah, definitely.
There's a problem though in that there's an assumption about the resource name and sort of the cardinality of it. It's sort of an abuse of the intended resource naming structure that it is this dynamic thing. Presumably here that red and blue in the networks example, that those are user provided names. And so that's sort of not the intended use of these resource names. The litmus test that I've put in front of other people, especially in the device plugins conversation, was that resource name should be plausibly a URL that I could hit and get documentation about that resource.
Mm-hmm. Mm-hmm. Right. That's not impossible, is it? Because especially because we're using the vendor string, that would be unique to the device plugin vendor. And in this case with red and blue, that vendor would then set up a redirect to an open API specification for that given network definition or network CRD or whatever it will be then.
It doesn't quite feel right to me, right. But I think I get where you're going. I think it maybe is missing a level of indirection in the sense of I don't think this is the right place to be representing the existence of a network. If you presume for a minute that the network CRD is a thing, and that the idea of multiple networks is going to proceed, right? Then what you really want the user to express is, I want to join network red and I want to join network blue, right? And that's all the user should have to express.
I see. Mm-hmm.
Then in looking at the definition of red and blue, there perhaps is an optional link to a resource class that says, if you want to join red, you have to get a resource from this resource class. And the resource class is maybe your SRIOV thing. And blue, well, that's just VXLAN, so there's no resource class needed. And then some admission control process says, in pulling this all together, it says, well, you've asked for network red. Network red requests resource class redNIC. redNIC means you need a device called foobar.com/ultrafast. And therefore, I will decorate your pod with a resource request for an ultrafast.
Yeah, I had actually jotted some notes down around this, and I was thinking, what if resources were somehow specified in the network attachment description, which means the CRD that we're talking about in the CRD proposal?
Yeah, I think we're on the same page,
That's
Dan.
the way that it could go.
I think we're on the same page there, Dan.
I think actually, sort of. I think there's still a level of indirection here, right? Within this kind of CRD concept we're talking about, there's still room for a class concept, right? We want to be able to make multiple networks of the same sort. They're just different individuals, but they all are of the same class, and it's at the class level you say, oh, well, this needs a PCIe channel.
It's unclear to me exactly the details because I'm just sort of waving my hands and sketching on a sticky note here. But I think that the relationship is, or rather, the line that we should hold is all the user should have to express to get into another network is that they want to be on that network. They shouldn't have to know anything about the network or how it's implemented, and the abstractions should cover the rest. And that may mean that we literally have to add an admission controller for network device linkage, and that's okay. I think that's completely a reasonable thing to do.
I mean, that said, in the example that Fabian has here, I feel like it's getting a little bit more complicated as we speak. But the user would only really have to specify, that they want to connect to network red, blue, and internal in this pod spec right here. So does that not satisfy that requirement, Tim? I mean, there's a little bit more typing with resources and limits in the networks.
Well, I think resources is the wrong place to represent it here, because I think the quantity here part of it is not appropriate. And I think the use of the resource name structure to sort of embed the user-defined name isn't really appropriate. I think it would make more sense in either an annotation or in a real field. If if this becomes a real thing, then it's a real field that says join me networks red and blue, and I don't, as an end user, I don't care what resources are required to join network blue. That'll get filled in for me.
Actually, I wonder how is that the definition? I'm actually I don't object with anything. I think it's a good point to say the user should have a few barriers to express what he needs, and all the prefixing with the vendor string should be not necessary to be done by the user. But I actually wonder, why should it be different for GPUs? Why should a user specify? Oh, well, for GPUs might make more sense, right? Because you want the vendor, you want to decide which vendor of GPU you want to use.
And again, it's sort of the fungibility of GPUs, right? Resource class literally gives you the ability to say, give me a fast GPU or a slow GPU, and I don't care what that means, just give me one. And some process makes sure that accounting happens correctly. And I know
you want 4.
Sorry?
Right? You want 4, right? These things are quantified. You ask for quantity. Maybe you run a job that wants 4 GPUs. You can ask for 4 GPUs.
That's right. But I don't think it's appropriate to request 4 links to the blue network. Now, I'm sure somebody's going to come up with a bandwidth throttling and counterexample here.
Well, I was actually going to ask about that, because we have talked in various places about quaz and bandwidth, and what does that look like here? For example, if you have a 40 gig NIC and a pod that wants 10 gig of that, how do we specify that kind of thing? And it seems like resources should be involved, but I don't really know what that looks like.
But most users, what sort of really, the infrastructure on the server is one thing, and you want to put networks on them, but should you really should it be that transparent that you see the type of devices and the capabilities here, and then go in and ask about that? I don't know.
I don't think we need to come to a decision here. My main intent was to start the discussion about that and take a look at it. And I
think you're successful in that point, at least.
And I thank for that vivid discussion, actually. Yep. But maybe it makes sense if we move to the demo, because we've prepared that, and I think it's quite nice work to see.
Yeah, let's do that. I was going to suggest that anyway. We've got 7 or 8 minutes left, so go ahead.
I would stop sharing, and I would hand it over to Peter, who did the really nice work.
Hello, I'm Peter, and before I jump to the demo, I just have a brief introduction to the device plugin. So what it does, it exposes connections to node bridges as a resource. I mean, it's maybe not the best usage of the device plugin for networks, but it was for POC, and I think it illustrates the case. So it is deployed as a daemon set, and it accepts white list of bridges as a parameter. We had to fight some problems with missing API points in the device plugin, and that is that we have only allocate call, which is it's called before the pod is actually created, so we don't have access to the network namespace of the pod. But we solved it with a hack, and there's ongoing discussion with the resource group about extending of the API, so we can have it handle it kind of natively, like having add and delete call to handle it like the CNI. So we have access to the network namespace. And I mean, I implemented for a bridge, but it can be pretty much used for a CNI as well. So let's jump into the demo. I will try to share my screen. Just a second.
Looks awesome.
Thanks. So I prepared the Minikube instance, and only extra thing I did there was that I enabled the device plugin feature gate. So let's jump into it. First thing you need to do is to create a config map, and this is the parameter for the device plugin, and the bridges here is a whitelist of bridges that should be exposed to the device plugin. The next step is to deploy the daemon set that contains the device plugin itself. And we can wait for it to be deployed. I mean, these two steps, the creation of the config map and the deployment of the daemon set, it's all you need to do to deploy the network solution across the cluster. From now on, it will be only usage of it, and it will take some time to download it.
Yeah, and maybe a side note. So this config map, the whitelisting of the bridge, is really just for this POC, where we settle with simple bridges to give that network connectivity to pods. Or CNI could be different.
So it's running, and I can ask Kubernetes to give me like available resources on the Minikube node. And so as you can see, there is the bridge resource exposing the my bridge 0, and there is 0 connections available. What that means is that the bridge was not created on the node yet. So in case I create a pod and I ask for this bridge, there won't be a place to schedule it on. So let's try to create the pod. There is a simple pod like Fabian showed. It's just asking for bridge, my bridge, and one instance of it. So let's create it. And if I try to get those pods, you can see that it's pending because there is no node to schedule it on. And now I can create the bridge itself. It's there, and now let's look into the available resources on the node. And now there is 100 connections to the bridge available. That's because there is no way how to express infinite resources for now, so it's just an arbitrary number. And if I get information about the pod, you can see it's not pending anymore, it's actually running. And now we can connect to the bridge, to the pod, and as you can see, there is my bridge 0, there's something, and that means that the NIC connected to the bridge was created inside the pod. And that's pretty much it.
Thanks. So that was the quick and non-invasive example of using a device plugin to bring an additional NIC to a pod.
So just to be, can I ask one clarifying question there? Just to be really clear, if I had 5 different tenants with 5 different networks, I would have 5 different daemon sets?
You had 5 different tenants with?
With 5 different virtual networks.
5
red, orange, yellow, green, blue.
Well, if you have multiple bridges, it's still handled by one daemon set. One resource type is handled by one daemon set. But if you have bridges and make VLANs, they can be implemented in multiple of them.
Okay.
So Tim, I tried to add some notes to the agenda doc. Hopefully didn't put too many words in your mouth, but if you want to take a really quick look at those and see if that accurately reflects what we were talking about 5 minutes ago, that would be great.
All right, will do.
All right, so we are at the top of the top of the hour. So thanks for the demo and great discussion. And let's continue the discussion on the mailing list and comments on Fabian's document, which I believe he linked to from the agenda doc. And we will meet in 2 weeks on March 15th.
Thanks. I appreciate the demo. It was a good conversation. I feel like I understand it much better than I did an hour ago. So
definitely.
I was very afraid of it an hour ago, and I'm much less so now.
All right. Thanks, everybody.
Thank you.
Thank you for listening.
Bye.